Let's talk about the triangle midsegment theorem. And first we have to know what a midsegment is. So if you look at the diagram here, you have point D. That is the midpoint of side AB. And we can tell that because of these little markings that say the segments on either side of D are congruent. Same thing is true of E on side AC. E is also a midpoint. So if you take the midpoints of two sides of a triangle and you connect them with a line segment, that line segment is called a midsegment. So that's what a midsegment is. And the reason we give a segment like this a special name is because it has special properties related to the third side of the triangle. So there's two key things that happen with midsegments and the third sides of triangles. First off, they're parallel to each other. And these are going to be things we'll be able to prove later when we get a little further along. That the midsegment and the third side are parallel to each other. And this is important because of what we learned early in the year about parallel lines and transversals. So you've got DE, you've got BC, and then the other sides of the triangle are transversals. And what you end up with is these pairs of corresponding angles. So if you remember corresponding angles, those are angles that are in the same position. So you have, for example, this angle down here, angle B. And then up here you have angle ADE. Those are both above the parallel line segment, and they're both to the right of the transversal. So they're corresponding, which means they are congruent. You have the exact same thing on the other side with angle C and angle AED. Those are corresponding angles, and those are congruent. So you end up with these two pairs of congruent angles with the midsegment and the third side of the triangle. The other thing, and I'm going to go ahead and write that these are parallel too. The midsegment DE and side BC are parallel. And just a reminder, that little symbol with the two vertical lines means parallel. The other thing that happens is the midsegment always ends up being exactly half the length of that third side. And there's two ways we can think of this or write this. We can say that segment DE or length DE is exactly 1/2 the length BC. So DE is equal to 1/2 BC. The other way we can write this, which this is the way I prefer, we can say 2 times DE. So if we take DE and double it, we end up with BC. Notice I wrote those without the little line segment thing over them. When we're talking about the length of a segment or the distance between 2 points, we write it without the little segment on top, and that tells us we're talking about a distance. So anyways, those are the two key things, and they're going to lead us to two types of problems, one with the angles and one with the midsegment and the third side, which is what we're actually going to start with. So here we have a diagram. It tells us that E and D are midpoints, which means that DE is a midsegment. So DE is a midsegment. And it gives us some information about DE. It says that's 9x minus 20. And about AC, which is the third side of the triangle. The triangle, the midsegment is not, or the side, the midsegment's not touching. That's 5x plus 12. So what we can do here is we can set up an equation. We can say if we take DE, 9x minus 20, and we multiply it by 2, we double it, it will be equal to AC, which is 5x plus 12. So if you take the midsegment, you multiply it by 2, it'll be equal to that other side. Now we can work this out. So I'm going to distribute my 2. I'm going to get 18x minus 40 equals 5x plus 12. And there's different ways to work this out. I'm going to add the 40 first. And I will get 18x equals 5x plus 52. And let's subtract our 5x. You get 13x equals 52. And when you divide by the 13, you should get that x is equal to 4. Now, that's the hard part. But it's not what we're actually trying to find. And this is where you have to be very careful. Often on these types of problems, like some other problems we've seen, the goal is not just to solve for x or whatever your variable is. The goal is to answer a certain question. And here the question is, what is the measure of AC? I'm going to switch colors here. So what is the measure of AC? So to find that, we have to take what we got for x, which is 4. We have to look at AC, which is 5x plus 12. And we got to plug in 4 for x and work this out. So 5x becomes 5 times 4. And we're going to get 20 plus 12, which is going to be 32. So that is our final answer. So make sure you don't stop until you actually find the length of whatever it wants you to find the length of by plugging in the x. So AC is going to be 32. All right. The other type of problem involves the angles. Now, the angles, we don't have to multiply anything by 2 because they end up being congruent. So here, it tells us that R and S are midpoints. So that means segment RS, this is a mid-segment. And it mentions 2 angles. It says SRP. So SRP, if you trace your angle from S to R and up to P, we're talking about this angle right here. And it says that is 10x plus 29. And then the other angle it talks about is QNR. So trace that from Q to N and then go up to R. It creates this angle right here. And it says that is 97 minus 7x. So if RS is a midsegment, we know that RS is parallel to the third side of the triangle, which is NQ or QN, which means our 2 angles that we've marked are corresponding angles, and they have to be congruent. So we make them equal to each other. So we can say 10x plus 29 is equal to 97 minus 7x. And we're just going to work it out. I like to get rid of any of my negatives first. So I'm going to add my 7x. I get 17x plus 29 equals 97. And I subtract the 29. 17x is equal to 68. And when I divide, I once again, and this is a coincidence because I picked these problems at random, x is equal to 4. So once again, we have x equal to 4. And once again, we're not done. So we know what x is, but we've got to answer the question. And the question here is, what is the measure of QNR? So QNR, that's the bottom angle. And it tells us that QNR is 97 minus 7x. So now that we know what x is, we can plug it in. There we go. So 97 minus 7 times 4, because x is equal to 4. We work this out. It's 97 minus 28, which ends up being 69 degrees. And if we look at the picture, 69 degrees is a reasonable answer. That in the picture, that angle looks like an acute angle. It looks like it's less than 90 degrees. So we would expect something in this range. So do little things like that to make sure your answer is reasonable. And again, don't forget that last step of plugging in the value of x. So that's mid-segment theorem. And again, you're going to have 2 types of problems. One involving corresponding angles that are congruent to each other. One involving the mid-segment, which is always half as long as the third side of the triangle. And there you go.